Hi. So yeah, we're Oglala Lakota College. We just start off by saying Hani Washte. We tonka machi apele mialo. Trey Phelps machi api oyates kaki. Sisitu ang bakate mata ha na miniluza ha. Um, basically saying we tonka is my Lakota name. Trey Phelps is my government name, non-native name, I guess you could say. I'm from Siston Wapton tribe, and I live in Rapid City. Um, yeah, and this is the rest of my team.
Hello, good morning. Traditionally, I'm known as Tashuka Sawi, which translates to White Horsewoman, and my English name is Michelle Sandy. I come from the Oglala Sioux tribe and the First Nations Muscapi Cree. I reside on the Pine Ridge Indian Reservation. I live just outside a small town called Kyle, or Little Woon, and I'm happy to be here today.
Ihaniwash Day. My name is Justina White Eyes, and I am from the Cheyenne River Reservation.
Yeah, I just wanted to also acknowledge Jason Tennant and Jim Sinovia, which are our staff mentors. We definitely could not have done it without them. And of course, Nathan and the EDSC crew. Okay, so the title for our project is Envisioning Resilient Campuses in a Changing Climate, which, but yeah, sorry, I guess basically we're kind of taking LiDAR data and trying to build a data infrastructure for all of our campuses. We have Oglala Lakota College is actually a decentralized school, so we have 10 different college centers throughout Western South Dakota, mostly Pine Ridge Indian Reservation, one in Rapid City and one in Eagle Butte. We're basically trying to build a data infrastructure for each of these college centers to kind of adhere to most responsible land use practices, and the best way to utilize resources, I guess, to be more environmentally conscious at all of our college centers. Kind of significance of our project, a lot of, of course, there's a lot of poverty and stuff on the reservations, and Oglala Lakota College can kind of act as a compass, I guess, to figure out what would be the best way to use resources, and kind of, I guess, pave the way for the rest of the reservation entities. I guess one of the first goals we have with all this is for the Greenhouse Initiative, Oglala Lakota Greenhouse Initiative, which means to basically build greenhouses on every one of the college center's lands. We already have one at the Hesapa Center in Rapid City, South Dakota. The next site that we have building is Little Wound or Kyle, South Dakota, the Pajutahaka Center, and Porcupine, Pine Ridge, and so on. Yeah, this is kind of the beginning of the data infrastructure, kind of an example. This is a Hesapa Center in Rapid City. This is kind of what we started out with. Here's our greenhouse. This is basically before we laid down any data. This is just a map that shows all of our college centers with respect to, on a scale of South Dakota as a whole. Each of the red circles is is a college center, and the ones that we circled are the ones that we did data for. Each of our team members did our own separate college center, so we all have separate notebooks and separate data. And these are the college centers just on the Pine Ridge Reservation, and we have 2 off the reservation. And I will hand it off to Michelle to explain the methods that we went through.
Okay, so our first steps were to download raw data, LiDAR data for the selected college centers that we chose, and to convert them so they were workable LAS files. And you can see the image on the right, left. That's the site we went to. And then we worked in ArcGIS to convert the LiDAR data to a bare Earth DEM, and process various raster and vector data sets. And we also digitized impervious zones in ArcGIS. And this slide, I'm just going to talk about what LiDAR data is. So LiDAR stands for light detection and ranging. It is a remote sensing method that uses light in the form of a pulse laser to measure ranges, variable distances to the Earth. These light pulses, combined with other data recorded by airborne systems, generate precise 3-dimensional information about the shape of the Earth and its surface characteristics. Next slide. So like I said before, LiDAR is one remote sensing method. This is just an example. It can be used to map structures, including vegetation height, density, and other characteristics across a region. Next slide. We used an open source, the LAS tool software. This software was used to convert the LAS files to the LAS. For each site, we had to convert 2 to 3 tiles. So in the picture here, it shows 2 tiles that we downloaded from the USGS site. And this was really confusing to get a hang of, but it was really fun to do. Next slide. And here's our processing steps we did in ArcGIS. So we went from point cloud data to converting it into a tin display. And from the tin, we went and made the bare Earth. And then from there, we've created the aspect, slope, and hill shade. Okay, so in this one, we are displaying our polygons in Python. So we had to set a path and open the data before plotting it. So on the left, you can see all of our polygons and the areas, the shape areas and the geometry. And then on the right side, we displayed our buildings. And this site is out to Peochoni. On this slide, for the Kyle area, the Pajutahaku College Center, we're gonna have to make some changes in the future because the data I was working with is from 2018. So it doesn't show the construction that was done for the new building. And that's on the left side of the screen, the old building. And on the right side is images from 2020 with the new location with the new buildings. Next slide. And Justina would take over from here.
This is the Pushitahaka DEM overlaid on the hillshade. On the left side is the code we used. And then the right side is the picture of the overlay. Okay, for this one, using Python coding, we were able to plot the data we gathered. And this shows on the left side, it shows our coding that we used. And then on the right side, it has the buildings contour, and then there's an enlarged photo in the middle of the buildings and the roads and all of that stuff. Okay, the final, our final maps will look like one. This is the Pine Ridge, and it's zoomed out. And we plotted the DM, hillshade, and slope, along with the boundary, parking lots, and roads, and the contour. And this one is Heisapa College Center. And this is, on the left side is the coding we used. And the right side is the outcome of the coding. Our data was not always up to date, so moving forward and looking into that. The Kyle College Center has large footprints with space for greenhouses, but needs to be designed with high wind. And previous zones will be difficult to shade. The Oglala Center, small footprint with room for a greenhouse with shade. Flooding concerns due to low elevation. Pine Ridge College Center, very small footprint. Small spaces for a small greenhouse could potentially shade with trees, and some slope concerns could possibly be addressed with riprap. Okay, next slide. The pictures shown are the 3D versions of the aspect, contour, and hillshade, and they're very detailed. Okay, the next steps we have are to process the remaining college centers, 3D modeling of all the college centers, creating a canopy cover, and then processing buildings and structures with our LiDAR data.